Okay, I'm also taking a video in case you guys need to reference it later. So yeah, I'll put it online eventually.
If I put an X here.
Okay, so we're going to be walking through the process of making a very simple silver band ring. This is what we're going to be. Where is this pointing? One of you guys might have to eventually help me with this. Okay. A very simple silver band ring, and then after we kind of walk through the steps of how to make it, we'll talk about the specifics of your project. But in like an hour, we're going to have a ring like this. So, the very fast overview of soldering. That's the technique we're going to be using for this project. Has anyone ever soldered anything before? Cool. Was it with a soldering iron or a torch?
Torch.
Oh, cool. Cool. So then you kind of know what we're doing. But yeah, for those of you who haven't done it before, soldering is one of the main ways that metalsmiths build three-dimensional forms. We're going to be constructing our ring and then our solder. We're using silver solder. This is what it looks like. So yeah, in case you care about the specifics, we're using sterling silver, which is 92.5% silver, and then the rest copper and other metals. That's if you ever have a silver ring, that's what it's made out of. And then we're using silver solder as our solder. This specifically is hard solder, so it's 75% silver and the rest copper and other materials. So the extra copper in this solder will cause it to melt before our silver does. So we're going to be melting a little piece of the silver solder into molten liquid metal in our seam of our ring, and it will, when we take the heat away, it will harden and essentially just fuse the two ends of our ring together. So that's the super fast overview. This is what we're starting with. Again, sterling silver, a 5mm width piece of metal and 16 gauge, so it's a little thicker than the metal we're working with. That's 20 gauge, so it's a little bit thinner. Yeah, and this is what we're starting with. So, step one for the ring project. Find out what size your finger is. What size ring you want to make, I guess. It doesn't have to be specifically for your finger, but you need to find out what size ring you're making. This is our ring sizer in that cabinet, normally. And if you look closely at these all have numbers on them. This is also U.S. sizing. Different countries have different sizing, so this is all U.S. American sizing. Yeah, if you look really closely, there are numbers on them. There's 2 of each number. So there's a 7 and a 7 minus, and the minus is actually like a half size. So if you guys can see that, I'll just quickly show it to you. So if you got a 7 minus, that's actually a 7.5, and you're just gonna try them on till you find one that fits you. And that's kind of up to your personal preference. Some people like tight rings, some people have a phobia of rings. They kind of freak out when their ring's too tight, which I learned only by teaching this class. It's usually guys because they don't wear rings as often. So I'm just going to try one of these on until I find one that fits me. This little ring that I made is a 4.5, which is that's my pinky size. Some people have small fingers though. The average woman's size, ring finger size, is 6.5, and the average male size I think is 9.5, 10, can't remember. But yeah, I'm gonna make a 4.5. So first step, determine your ring size. Second step, find this chart, which is also in there. This is gonna tell me how long I need my piece of metal to be, so that when I bend it around into a circle, it is the correct size. Lots of numbers on this chart. The only thing that you need are the far left column and then this middle column that has stars on top and on bottom. The far left column has all the sizes on it, and then so I'm going to find what size I want to make, If you feel like you're in between two of those, this also has quarter sizes, so I can make 4 1/4 if I wanted to. I'm gonna make a 4 1/2, and then I'm gonna go over to this middle column, find where this intersects with the middle column, and that's how long I want to cut my metal. So this says 51.8, and that refers to millimeters. So jewelers use a metric system. Yeah, we're using this middle column. It says 16 at the top, and that corresponds to the gauge of our metal. So if we had a thinner piece of metal, our ring would, our like starting material would be shorter. What did I say it was? 51.8, 51.8, 51.8. Okay, so in order to cut 51.8, I'm gonna find one of these little rulers, also in that cabinet in the little white container down there where the files are. In case you haven't done metric in a while, it's always is a problem. We're using the top side with the littler numbers, sorry, and each number is a centimeter, so that's 10 millimeters. So 58 is like 5 and then 8 little marks. I'm not cutting like 50, right? Because that's not a ring size. That's like a belt. Yeah. So that has been an issue before. Each little mark on here is a millimeter. Actually, the first 5 centimeters has 1/2 millimeter marks as well, which is confusing sometimes, but also can be helpful. So you are welcome to like do whatever you need to do with this roll to make this easy for you. It's kind of heavy right now, so what was it?
51.8.
Thanks. I was thinking it was 58.1. 51.8. So if you have like a fraction, 1/2 of a millimeter is so tiny. I would suggest just rounding up, just rounding to the nearest whole number. So I'm going to do 52. I'm going to be filing my ends, so I'll actually be removing a little bit of material. So that should leave me right about perfect. 52. I also want to use a little scribe when I make my mark. This is just a sharp piece of steel. It makes a really fine little scratch. If I use a Sharpie, like the width of this Sharpie is 2 millimeters, so that can really throw off my measurement. So I want to make this little scratch. I don't know if you guys will see it. Just a little tiny scratch. Camera, can you see it? Probably not. And then I'm going to saw this with my saw. Make sure that you use your saw. For some reason, people always want to try to use like these snips to cut through your metal, and this is thicker than our other metal, so it's going to be tricky to snip through it. Also, it's going to leave your end all jacked up instead of, you know, a nice, sharp, crisp cut. So, maybe get a saw blade out. Sterling silver saws pretty similarly to our other metals. It's actually a little bit on the softer side, like copper. And it is a little harder to cut just because it's a little bit thicker gauge, so it's thicker this way, but it's also kind of thin this way, so it likes to wobble a lot. So it's a little bit harder to start. Okay, so now I have my piece of metal. Ooh. Eventually, this will become the same size as that, which is kind of crazy. Looks way too small, in my opinion. So yeah, once you have your piece of metal cut to the right size, The next thing I need to do is file my ends. So there are 2 tedious parts of this project. Is anyone a perfectionist? No. Okay, well, this is your time to practice. Yeah, 2 tedious parts where you need to be a perfectionist. This is the first one. My goal is to file the ends of these pieces so that it's like perfectly perpendicular to my edges, right? So my corners are 90-degree corners, and I don't have, I tried to draw this up, perfectly crisp. Those are my rounded corners, that's what I don't want. Silver solder is a little bit different than other solder in that it doesn't like build up on itself. It's not thick and globby, it's really runny. So if you have any gaps in your seam, it just won't fill them up. Then you have a weak solder seam and your ring's gonna pop open. Then you start over and you're sad. Okay, so I need to file these perfectly flat. Kind of like they're manufactured that way, right? Like it just came like that. The easiest way to do that is to hold it right up to the edge of the table so that you're kind of filing along with the surface of the table. That helps it be flat, rather than like filing in the air. You're not totally sure what angle you're going at. And I'm gonna be like very gentle here. Gentle, precise. If you look at your metal as you're filing, you can watch it become flat or become unflat if you're filing not flat. The point is you can watch it change. A lot of times when people are doing this step, they're just like, right? Not paying attention, and then they get frustrated at how long it takes them. So give it your full attention. Also, I think a lot of times people have trouble like telling if it's flat. Like just seeing it can take a little practice as well. The back part of your file is machined to be perfectly flat. This part right here. So if I can't really tell, you can hold it on there like this. Hold it up to the light. You shouldn't see any light coming through on the corners. So my piece is flat, but actually, like this is a flat plane, but it's a little tiny bit at an angle like that. So I'm gonna keep fixing it until it's perfect. Taking the time to get it right now saves you a lot of time in the future. It's worth it, I promise. Even though it can be frustrating. Still a little sideways. Can you guys see this little dust pile? This is why I rounded up a little bit, because this is making my metal shorter the more I file. Okay. I can't let it go. Okay, I also want to make sure that it's flat like from the side view. So a lot of times from the front it will look like it's straight, but then from the side view it's actually at an angle. So I want like 360 view, everything flat, all my corners, 90 degrees from every direction. This one's still just slightly not totally flat, but I'm gonna make it work. You guys want to look at it, that's what you want, that's what you're going for. This one is one that you're not going for. So if you look at the edges of this, like I wanted my filed ends to look like this edge, machined edge, perfectly flat, one smooth flat plane. This one has like a couple like the surface is a little bit faceted. You can see a few different planes, and the corners are kind of knocked off. So that's what you don't want it to look like. And again, it's worth just taking the time to get it perfect, even though it's frustrating sometimes. Any questions so far? Okay, our next step is bending those two ends around until they meet each other. At this point, I don't care that it's round. is not going to be round. Don't worry about it. The round comes after we solder the ends together. If you try to make it round, again, not great at drawing, but if you try to make it round, if you guys can see this picture, there's actually going to be a little tiny minuscule little gap at the top, and our solder doesn't like to fill gaps. So we're going to bring our two ends straight in towards each other, so that entire surface I filed on both ends is touching completely, no gaps. Second tedious part, getting these to match exactly. If you're making a small ring, bending this metal by hand can be a little tricky. So we have pliers in there that you guys are welcome to use. We have a variety in there, so make sure you're using the right ones. I want to use flat pliers, flat nose pliers, so the inside is flat. Some of them are round. That's not good. I want to use flat ones. Also, again, not using snips. These have a cutting edge. That's not what I want. I want to use these flat nose pliers. Our silver is pretty soft, and these are steel. So if I just like start going to town and bending, these have really crisp, sharp corners, and they'll make a ton of dents and scratches in my metal, which then later I get to sand out, right? I hate sanding, so I usually put tape around my pliers just to kind of soften those sharp edges and help keep my metal safe. You don't need a lot of tape. Like some of them in there are just unusable because of the amount of tape they have on them. So makes it really hard to grip anything. You just need a thin layer, and then double check and make sure the corners aren't poking through your tape yet before you start. Okay, so the first thing I'm going to do is I'm basically going candy cane shape at first. So if I turn my wrist over so my wrist is pointing up, my palm is pointing up, and grip the end of this thing, and then I'm just going to flip this corner in, candy cane style. And I will do the same thing with the second side. And so yeah, it's going to look way more like an oval than a ring right now. That's okay. So my goal is to get these to line up perfectly so that they look like one continuous piece of metal just with a little tiny crack in it, right? So that means from the top view, I want my sides to line up and not be offset. And then also from each side, making sure that, again, they're lined up in a perfectly flat line. So yeah, second tedious part is just getting these to match, to touch with no gaps. Your metal is strong, so you're gonna have to be pretty aggressive, and don't worry about breaking it. But if you're having trouble closing your gap, it actually helps, can you guys see that? To overlap your pieces, like push one past the other one and then pull them back. That's kind of what's making this snap noise. And that's kind of the same as putting our saw blade in with tension. Now these two ends are like pushing against each other, which helps make for a stronger solder seam. Okay, so not lined up from the side yet. You guys have questions? Sorry, this part is not very exciting.
Do you make rings a lot in your jewelry shop?
Yeah, but I actually usually cast things instead of fabricate them like this.
Pour the liquid metal into wool.
Mm-hmm. Yeah. You just have a lot more options for like variety and like this is just a flat ring, so if you wanted to make something that had more volume to it, usually those are cast. Any other questions? Also, just expect to take a little time on this. I know it's taking me a while. but it will take you longer.
Oh, shoot.
I've done this so many times, so don't get frustrated when it takes you a while. Okay. So I also want to be able to hold this up to the light and not see any like gaps. Yikes. Okay, I'm gonna just be done. If you look closely, one of the sides is a little bit off. So actually my like one side is twisted a little bit. It's like a fraction of a millimeter. If I were really making this for real, I would fix it. But since you guys just have to wait for me.
Is that from filing it wrong or putting it in wrong?
It's just from like when you bend it over, sometimes you bend it and it twists a little. So it just needs to be like untwisted. Yeah, it's just kind of a lot of finagling, wiggling, bending until everything matches up. I have one that, okay, so this is one that is a bad one. If you look at it, you can see the ends weren't filed flat, so you definitely have those rounded corners. And they're huge, if you hold it up to the light, really big gaps. And it doesn't really line up from the edges either. So this is not going to solder well. It might look like it's soldered, but when you try to hammer it around into a circle, the seam will just pop open. And then you get to file and bend all over again. Okay. Any questions? So after we get to this point, we're ready to go solder to our torch. So once you guys have seen them both, if you want to walk to that far little table over there, we're going to talk about how to actually do the soldering. Do any of you guys want to try to man this video camera? Anyone want to be a videographer of the day? Yeah? Oh boy, just don't put me in it, okay? My face. So. What?
Is Troy here?
I don't think so. Oops.
I just saw Jim.
Kelly?
Yeah, I gave him your phone number. He's got something for you.
Okay. Okay, so this is our soldering table. This is where we're going to be doing all of our soldering. A few first safety things. We are using like an open flame, so if you have long hair, you should pull it back. Your hair will catch on fire. It has happened. Also, anything that will hang down, so like hoodie strings, big old scarf, all of that stuff should be removed before starting this. Just in case, there is a fire extinguisher right here if you need it.
I didn't know. I ignored it.
Okay, so I'm going to be doing all of my soldering up here on this brick. The first thing I'm going to do is get my torch ready. So this is our torch. I'll pull it out so you all can see it. There are multiple different types of fuels and torches you can use for metalsmithing. The studio over there uses natural gas, but we're using acetylene. So the fuel in this tank is acetylene. That's the gas that we're going to be using to create our flame. This whole contraption looks confusing, but it's not. This whole part you guys don't need to mess with. That's just the regulator. It tells you what pressure, how much gas you have, and what pressure it's coming out at. Don't need to worry about that. The only thing you need to do is open the tank so the gas can flow up our hose to the torch tip, and that's going to happen right here at the top. This little key, there is a sign on here that says this way is open, that way is closed. So I just want to turn it until I feel it release, just like a little quarter turn. I don't need to crank forever. So again, you kind of have to hold this, but just until you feel it release. Also, this you guys don't ever need to move. It should stay back there. These are actually dangerous if they get knocked over, which is why it's in like this contraption. But, so just leave it back there and everything will be fine. Okay, so I'm actually gonna move this table out so you guys can see better. Beep beep. Okay, so the first thing I want to do now is prepare my ring. If I just start like torching this ring, it's going to get severely oxidized, which means it's just going to turn black and disgusting. And my solder does not like to melt when your metal is clean. Sorry, when your metal is dirty. So the first thing I want to do is cover this in flux. Flux is this, in this jar, white pasty stuff that will help protect your metal through the soldering process. So I just want to find a paintbrush. This, oops, gross. Some form of paintbrush. And I want to paint this on the entire surface of my ring. So outside, inside, backside, all the sides, all the places. Just as a heads up, this is toxic in that like you shouldn't eat it, right? If you get it on your fingers, don't like lick it off your fingers. Yeah. Also, if you have cuts, you should put a Band-Aid on because it will sting if it gets in your cut. But it will not hurt your clothes, so you can wipe this on your clothes if you want to. I usually have white junk everywhere. Or right here. Yeah. So I have my flux on. I put a fairly like thin layer on. I don't know if you guys can tell. I don't have like that, right? You'll kind of find out why later, but I want a thin coating. Okay, and now I'm going to cut my solder to put on my seam. So there should always be some over here. These little silver wires, you should be able to find them somewhere. Yes, little skinny wires. What we don't want to use is this thick wire. This is nickel. This is a slightly different color. I don't know if you can tell. This is the same that we're using for our project. This has a way higher melting temperature than our ring, so if you try to use this, you're going to melt your ring into a big puddle. So I want to use this skinny little wire. Should have some bends in the end. That kind of helps you know. Got it solder. And for the size seam I have, like it's pretty small in terms of soldering seams. So I just need 2 tiny specks to fill that up. And I'm gonna make you look at them. By speck, I mean literally a speck. Can you go speck? Can you see it?
Yeah.
Maybe, maybe not. Okay. Little speck, tiny speck, itty bitty speck. This speck is going to melt into a puddle, and it's going to fill a lot more surface area than it looks like it's going to because it will be liquid, which is cool. So I really just need 2 of these. You can cut extra, they're very easy to lose. So yeah, once I have my solder cut, I want to put them on my seam. It's very hard to pick them up with your fingers, again, so tiny. The easiest way to use one of these, which is a solder pick, just a piece of steel. If you dip it in your flux and then touch it to your solder will just stick right up there to it. It's way easier than trying to use your fingers. Okay, so my goal is to put them directly on top of the seam, and then one on either end of my seam. So if y'all want to look at that, that's what it should look like before you start. What's your goal? Okay, so I have my flux on, my solder on, I'm ready to solder. So I'm going to get my torch out. And so far, the tank is open, but there's no gas coming out. This is the second valve that will allow the gas to flow. You can hear it when it's on, right? We use strikers to light our torch, so make sure you're using one of these, not like a lighter. This flame is very hot, so if you try to light it with a lighter, sometimes it will melt the plastic of your lighter and ignite all the fuel into a big fireball. Not good, right? So if you haven't used one of these in a while, have you guys used these? Oops. Sparks. Okay, these sparks are harmless. They literally can hit you and you can't even feel that they're hot. So don't freak out about it. The easiest way to create sparks. So this side is the movable side, it has a little flint on it, and that will strike against the textured steel to make a spark. So the easiest way to do it is to put your thumb on this part that moves, right? So you can like push down, make some good sparks. If you hold it underhand like this, it's harder to get sparks. So thumb on it, be aggressive, get some sparks. Cool. If you haven't done this in a while, I'll just suggest that you practice before you solder. Okay, so again, I want to use this side knob. I don't ever want to turn this. Someone was doing this the other day. This loosens, like this makes the torch tip come off, and then there's just gas coming out here. So make sure that you're using the side knob and not this top knob. I usually check and make sure this is tight before I start, just because you never know what people do around here. Okay, so away from me, that lets some gas out. I just need a little hiss. It's small. It's loud, but it's small. Okay. Towards me turns it off. It does pop a lot, but that's it. It's fun to do. Smells good. Okay. A couple kind of things to keep in mind. If you notice, there's a little flame that shoots out here when you turn it off. It's not going to hurt you. Right? Don't be scared. If you turn it off too slowly, sometimes it will make a horrible hissing sound. That means it's just not all the way turned off. You guys are welcome. There'll be time for you to solder in class with me helping you if you want. You're also welcome to do it outside of class if you want. Okay, so I need a smallish flame. I don't need like full-blown flame. Just a little bit smaller. I'm gonna stand back here so you guys. Also, I forgot to tell you, when you solder, the flux does release some fumes. So this thing, usually you'll solder with a table back there, sucks up all the fumes, then spits out clean air somehow. I'm not gonna use it. Okay, so if y'all want to come in here as close as you can. This happens quickly. And it's very tiny. Okay. I am right-handed, but I hold my torch in my left hand. The flux is water-based, so when the water evaporates, sometimes my solder shoots out of place, and then I have to poke it back where it goes with the solder pick. Also, if this is all dried up, someone left the lid off, you can just add more water and crunch it up until it gets back to like that paste consistency. Okay, so my goal is to heat up this side of my ring and this side of my ring evenly. If I heat up only this side, when my solder melts, all my solder will jump over here instead of sucking down in my seam. So I need this side to be evenly hot as that side. The easiest way to do that is to go straight down and not like at an angle. That way you have a little more visual idea of where your flame is going. So I'm going to go straight down and then I'm going to move back and forth across the surface of my ring. The flux will go through a few stages that help you know how hot it is. We're going to do that again in a second. But back and forth. Right before my solder melts, my flux will get really shiny. I don't know if you can see, now it is shiny. And then it's going to ball up in a little ball. Did that one move? Oh, okay. It's going to in a ball, and then it's gonna melt into a puddle. So it just barely melted. So it should, you can see it, shiny, shimmery little puddle. As soon as you see that shiny, shimmery puddle, you want to take your torch away. If you keep heating it up after that, you can melt your whole ring. So again, shiny, shimmery puddle. Can you see that? Shiny, shiny, right? Only on my seam, not everywhere else. Yeah, so kinda, now my seam is soldered. It's a little bit hard to see. So the next thing we would need to do is clean this off and like actually make sure that it worked. This is hot, right? Don't touch it with your fingers, please. Use some tweezers. There should be, I'm gonna clean this up, it's kind of a mess. A few pairs of tweezers. These are cross-lock tweezers, so you have to squeeze the back to get them to open. But I'm gonna pick this up. Sometimes if you use a lot of flux, it'll get stuck to this brick, so you kind of have to pry it off or heat it up again. And I'm gonna drop it in this little crock pot part. Water. That process is called quenching, so I just drop it into water. That noise is the water around it boiling, which is cool. And then my ring is like, as soon as I drop it in there, automatically the temperature of that water, so I can touch it as soon as it's been in water. So yeah, I don't know if you guys can see. It is, if I didn't use any flux, my whole ring would be black, just like that seam is kind of black. And there's some black stuff back there. And then all this like blue stuff is the flux. So I need all this to come off to see whether or not I actually have solder like on that seam. So we're gonna go to the sink and then we'll be back over here. Thank you. Yeah. Okay, I'm actually using this. Okay, so I'm gonna dunk my ring or ring in. What's submerge? Here we go. That's the word I'm going for. I'm going to put my ring into this solution. This is called pickle. It says on there. It's a very mild acid solution, sodium bisulfate, which is used in pools to regulate the pH. So it is acid, but it's not going to hurt you. Like, you won't get an acid burn. You can get it on your skin. If you have a bad cut, it might sting a little bit, but in general, this is not like bad acid, so don't worry about it too much. The one thing that it will do is eat like tiny little holes in your shirt though, and your clothes. So try not to splash it on yourself. Drop it in gently or like use the lid as a shield so that you don't get like little itty bitty holes eaten in your shirt. I'm gonna leave that in for anywhere between like 5 to 30 minutes depending on how dirty it is. Like if it's totally black, you're gonna need probably about 30 minutes for it to get clean. So yeah, I'm gonna leave that in there. We're gonna go back over there. Actually, first, also if you decide that you don't want to drop it in with your hands, you will need to use copper tongs. Here they are. So they should be around here somewhere. These are different than the ones that we use over there. Those ones are steel. These are made out of copper, which you can kind of see, dirty copper. Anything that goes in this pickle solution needs to be non-ferrous, which means not iron, not steel. So make sure you use these copper tongs. If you accidentally put steel in there, it's going to change the whole chemical composition so that anything you put in there gets plated in copper. So if someone puts steel in there and then you put your silver ring in there, it will come out copper, like this, which will not be cool because that's your ring. You can sand it off, but it sucks to do that. So if you accidentally put steel in there, just let me know and I'll make a new batch. Way easier than sanding copper off of your rings. Yeah, so we're gonna leave that in there and then go back to the soldering table. I'm gonna wash my hands. Even if you do stick your hand in there, I would probably suggest washing it. instead of just walking all over that. Okay, while that cleans, we're gonna do 2 more fast things over here. Just to help you see a little bit more solder melting so you can get an idea. I didn't mention, but you can solder any of the types of metal we've been using so far. So like I can build a huge, crazy thing out of copper. I can mix metals. So generally I want a thin layer of flux. I want you guys to see what it looks like if you put on too much. So don't do this, right? We're just gonna melt. Also, we're gonna use like gigantic solder. Oops, missed. This is gigantic in the world of solder. I know it doesn't look that big. So let's see. For this one, we're gonna kind of discuss the stages of the flux. That will let you know how close you are to your solder melting. So, yeah, since the flux is water-based, the first thing that's going to happen is the water evaporates. So this is called the popcorn phase because it kind of pops around like popcorn, and it shoots your solder like all over the place. I don't know, this one was over here, that one was over here, and this one is like in here somewhere now. So that's why I don't want to use too much flux, because I lose all my solder somewhere. Where did you go? There you are. Okay. After it goes through that popcorn, so it's like popping all over the place and is white, then it will start to become clear and glassy, so really shiny, like and clear, which it is right now. Clear, super shiny. Looks like glass. Once it gets clear and shiny, like right now, that kind of indicates that your metal is getting hot enough for your solder to melt. So it will ball up in a little ball and then spread out in a shiny liquid puddle. And again, as soon as you see your solder shiny shimmery puddle like this, right, liquid, you want to stop. This is, yeah, if you keep heating your metal too much, it will turn totally black. Yep, dirty metal. The pickle will clean all that off, so it will look like copper again. Last thing we're gonna do over here is to melt some silver, so you can see what it looks like if you heat your ring up too much and it melts. You can't really come back from that, so I'm gonna try to give you, let you see what it looks like, so maybe you can avoid it. Okay, so that's like a little half ring, and some solder on it. So we'll put a couple pieces of solder on here. Again, these are gigantic and don't really want to use ones this big. But also, if someone has lots of people have been soldering before you, this torch tip does get hot, as does the brick. So before you like just grab this by, kind of hover your hand over there and see if it is too warm to touch. Okay. So the piece of copper was way bigger, so it took a lot longer for my solder to melt. But this is all going to happen way faster on this little piece of metal. So So do you guys see my solder melt? As soon as it melts into a puddle, again, I want to stop. If at any point I see any other part of my metal shimmery, that's bad. That means it's melting, right? So if your ring starts like folding up, collapsing, you want to stop. You definitely want to stop before you get here, right? Liquid metal. Cool, it's boiling. That's how hot it is. Cool, cool. Not a ring though, right? So as soon as you see your solder melting, stop. Or you could end up with that. Where did I put the tweezers? So yeah, this is what like your metal looks like if you don't put flux on it, totally black. But if I put this in the pickle, it will all clean off and it will become like totally silver again. Which again is cool, but is not a ring. So just be careful. When you guys are done over here, make sure you put the lid back on the flux. Since it is water-based, it will dry out. And then I also want to close the tank to the gas. So just close this knob up here until it's all the way tight. And that way, this tank actually has a little leak in it. So if you close it, we won't lose all of our gas overnight. Okay. Y'all have any questions about this? Let's go check on our ring. We're almost done. Okay, so I'm going to take this out again with the copper tongs or my hand if I wanted to. It's not all the way clean, but it's getting close. Like all the blue stuff is gone, and now I just have like a little bit of black gunk, a little bit of oxidation. So if I leave it in there, it'll all come off. But at this point, I don't really care. Eventually, I'm going to be sanding this anyway, so for this ring, it's fine that it looks a little black. So I'm going to rinse it off, and we're going to go back to the table, make it round. That's our last step. Because I'm going to hammer pretty hard, and I don't want it to fall out. Thanks. Okay, in order to make this round now, actually first I kind of want to just look at the seam and see if it looks filled in. Sometimes it's hard to tell, but if I see like a hole, like a black negative little crack, that means it's not filled in. If you're not sure, you can always just try to make it round and see what happens. So yeah, I'm going to hammer this around my ring mandrel, which is just this tapered piece of steel. In that cabinet, normally, we have a second one, I think it's in that cabinet for some reason. But most likely at first your ring is not actually going to fit on there, right? So I need to kind of hammer it open a little bit before I can actually fit it on this ring mandrel. So in order to do that, I just want to stand it up, tall, skinny, long ways. And with a soft hammer, not a steel hammer, I will just start to slam it. Hopefully not slam your fingers. Yeah, this is your moment of truth, right? So if you didn't do a good job soldering, your seam is just going to pop open, and then you get to kind of like do that over again. If you're having a hard time opening it, like the skinnier it is, the harder it is to open. You can kind of also use some pliers to help you. Again, make sure that they're taped well so you're not making dents in there. Yeah, once I kind of, it's gonna look bad right now, guys. Don't worry about it. There you go. Okay. So once I can fit it on there, I want to fit it on there. And then I'm going to hammer it wherever it is not touching my mandrel. So all these big giant gaps, those are the parts that I want to focus on hammering. I'm going to have to hit pretty hard. I don't know if you guys noticed hitting pretty hard here. So just this, not a great method. Might work eventually. The best, easiest way to do it is to put the tip of it on the table and then you're going to hit it way harder. Whoops. And you can drop your ring. So yeah, anywhere where it's not touching my ring mandrel, gonna hit it. You guys awake yet? It also helps if I take it off and then flip it over, put it on the opposite way. That just kind of helps to get everything round and keep it even, so you don't have like a tapered ring. If it gets stuck on there, which it might, if you flip it over, you can kind of hammer it off. And right now my ring is still kind of lumpy. I don't know if you guys can see that. Not a perfectly round circle. So I'm going to continue hammering until I get a nice perfect circle instead of this like lumpy, messed up circle. Also, you can kind of test your ring size or find out whether you like did a good job measuring by putting it on here. This top part's kind of messed up, but this has all the ring sizes on it as well. So wherever the bottom of my ring lines up with, like right now this is at a 4, almost a 4 1/4. Once I finish hammering it round, it should be a 4 1/2. If it's not perfectly round, it's not going to be accurate in sizing. But yeah, so there's that. You guys can look at it. I will eventually hammer that more. If you have a ring for someone else, like you don't want to make a ring for yourself, that's fine. If you have one of like someone else's rings, you can kind of find out the size on here if you don't know their ring size. Yeah, any questions? Okay, that's all we're doing today. Thank you.